friendly. We stop people from walking in front of the camera. If you need to go, please go behind the camera. Everyone will get your image. Thank you. All right, my name is Mr. Sims, and this is AbZero. We call it AbZero for short. And AbZero is a math game that we're going to play using numbers which become puzzles. 3 numbers constitute a puzzle. You can also do 4 numbers or 5 numbers. The whole goal of the AbZero game is to take the 3 numbers, let's say 6, 5, 0, and manipulate them to give us an outcome of 11 or any multiple of 11. Multiple of 11 is a number which 11 is multiplied by. So, multiply 11 by 2, you get 22. Give me a moment, let's get this part done. You get 22. 3 times 11 is 33. 4 times is 44. 5 times is 55. 6 times is 66. 7 times is 77. 8 times is 88. 9 times is 99. 10 times is 110, and it goes on and on and on. You can always check or prove yourself, because whatever number you come up with, if you divide it by 11, then you will end up with a whole number with no remainder whatsoever. Okay, so in the case of 650, we'll get to that in just one second. I just want you to know what numbers constitute 11. So 6 and 5 is always going to be 11. 7 plus 4 is always going to be 11. 8 plus 3 is always going to be 11. 9 plus 2 is 11. And 10 plus 1 is also 11. To begin with the number 650, you can see that 6 plus 5 equals 11. So we can always say that 6 plus 5, if you do something with a 0, 0 can be used as either 0 or 10, but not both. So you can add it to 11. 65 equals 11 plus 0 still equals 11. Same thing with 6 plus 5 equals 11 minus 0 is still 11. But what if we want to use the 0 as a 10? 6 plus 5 equals 11 times 10 equals 110. And that corresponds with the answer right there. 110 is a multiple of 11, and therefore it's a solution. And we always mark a solution with a little star on it. Absolute zero can be used in so many ways. You can use the numbers up here using math, all sorts of math functions, from multiplication, division, addition, subtraction, square roots, exponents, even factorials. And we've looked at some of those throughout the past few weeks that we've been doing this class. You can also combine numbers. So in the case of 650, you can use it completely as 650 if you have a use for it. Or you can do 6 and 5, you can combine them to be 65, plus or minus, the 0 uses 0 or a 10. You can combine the 5 and the 0 to equal 50, and then you have a 6 on the outside that you have to use. And of course, you can combine a separate function would be to multiply 5 times the 0 uses 10 to equal 50 also, and that's a different function. So if you came up with a solution that incorporated 50, you could either use the 5 and 10 to combine them as 50, Or you could use 5 times 10 to be 50 also, and that would be a separate answer or a separate solution. There's so very many ways that this particular puzzle can be used. Well, let's investigate just a couple of those ways. This is what we call running numbers. We'll do some addition and subtraction, we'll do some multiplication and division. Let's take a look and see what we can get. We've already done 6 plus 5. 6 minus 5 won't work. Well, actually it will, I'm sorry. 6 minus 5 equals plus. What is 6 minus 5? 1. We have 1. Now we still are left with a 0. What can we do with the 0? We can use it as a 10. So 10 plus 1 equals 11. And that corresponds with 11. That's what we're shooting for. In arriving at scores, any score that, or any solution that is above 11 scores a positive point, or any solution that's below 11 scores a negative point. So let's say, let's say we scored 15. This is actually not a score, this is a solution. The solution, if it came out from 15, we'd look at where that falls compared to 11. Is 15 above or below 11? Above, okay, so we know that. So it'll be a plus. How many numbers is 15 above 11? 4. Good. So we have plus 4. 4 and 11 is 15. If we had a score, if we had a solution of 8, is that above or below 11? Below. Good. So it would be minus. How far below 11? 3. So an 8 would score minus 3. As if 11 is par, it equals 0. So any number above 11 is plus that number, or any number below 11 is minus that number. And then in the end of some of these puzzles, we'll be able to have the positive and negative numbers offset each other so that we can possibly arrive at 0, which is absolute 0, which is what the game is called. Okay, let's look back on the 650. This is a very interesting number. Gives us a lot of possibilities. We've done addition, we've done subtraction. How about multiplication? How much is 6 times 5? 30. Then you have plus or minus 10. With plus 10, it equals 10 and 30 is 40. That doesn't work. Okay, we can discard that. Because 40 would have to be 44 in order to be a multiple of 11. How about 30 minus 10? 20. And we have to be at 22, so that doesn't work. So that multiplication doesn't work. How about 6 times 10, using the 0 as 10, equals what? 60. Now we're left over with the 5. What can we do with the 5 to get to our goal? How about if we add the 5? 6 plus 5 is what? 65. And that doesn't work. We have to make it to 66. How about 60 minus 5? What does that mean? 55. And is 55 a multiple of 11?
Yes.
All right, so we have one solution. And how we arrived at it is running the numbers. And we can go further, and I'll just give you these. 5 times 10 equals 50. You saw the 6. If you add the 6, it's 56. If you subtract the 6, it is 50 minus 6. Close, 44. Okay, is 44 a multiple of 11? Then that is a good answer. So that's about 4 so far, and it goes on and on. Okay. Now let's go for a new take, please, on the camera. Okay. Last week I asked you to bring me some numbers, some license plates. This game was originally designed to be played with license plates because that's what I saw in traffic. And so we had the students go out and look at license plates as I either pass them on the street or in traffic, and to bring me some and see if we could solve them. So, can you name off one that you brought along for us, please? You don't have to bring it up, just name whichever one you like. And we'll try to solve it. 3, 4, 384. Okay. 384. So the first thing that we're going to look at is, do any of these numbers correspond to 11 up on the top? And yes, 8 and 3 do. So we can do 3 plus 8 equals 11. And if we're at 11, any number that we multiply it by is going to be a multiple of 11. So, if we multiply that by 4, I heard you, 44. And that corresponds with a solution. So we get the star. Can we see any other ways? Let's do some running of the numbers. 38 plus or minus 4. 38 plus 4 is 40. That doesn't work. 38 minus 4. It's 42, I'm sorry. And 38 minus 4 is 34, which is one more than we need over here, so that doesn't work. How about 84? 84 plus 3 is 87. That falls one short of 88, which is the number that we would need. So that doesn't work. And then 84 minus 3 equals 81. That doesn't work either. So, we could go 3 times 4 equals 12, plus 8 would be 20, and 20 doesn't make it up to 22, so that's no good. I think we've run just about through them all. Let's see. Okay, I'm doing some exponents. 4 to the third power is 4 times 4 would be squared, would be 16. And then 4 times 16 is 64. So that's 4 to the third power, 64, plus or minus 8, or times 8. If we divide it by 8, that's of course 8 again, so that's still not going to get us to where we need to go. And 64 plus 8 or minus 8 is not going to get us to where we need to go either. So I don't see anything else in that vicinity. Now let's take a look at factorials. Factorials are the number multiplied by every number that comes before it going down to 2. So 3 factorial would be 3 times 2, and can't go any further, so that would equal 6. And we express 6 with an exclamation mark. I'm sorry, 3 of the exclamation mark. That's 3 factorial. Now let's plug that in. 6, 8, and 4. Okay, there's one. How about 6 times 8? How much is 6 times 8? 48. And you're left over with a 4. What do you do with the 4? That's right. And 48 minus 4? 44. Running out of room. So that is the second possibility using factorial, which is a little bit higher math than most of us in grade school are prepared for at this time. But there are so many answers to so many numbers. Have one more? Just call it out. 594. Okay. 594. So does it match with anything up there? No, if you have 2 and 9 and 2 would be 11, or 6 and 5 is 11, and we can't quite get there. If this was a 10, and we subtract the 4, and then it gives us 6 and 5, that would give us a solution. So we're going to have to get a little bit more crafty. And this is actually a good number because it deals with reciprocals. Okay. 5 times 4 equals what? 20. Okay. And we're still left with the 9. What do we do with the 9? Subtract. Thank you. 20 minus 9 equals?
11.
And that corresponds with that, so that's a good number. Let's take a look at using the numbers and looking for reciprocals. Whenever you find 2 numbers that when combined give you the opportunity to reach a goal, such as 5 and 9 can combine into 59. 59 plus 4 equals 63. Oh, yeah. 59 plus 4 equals 63. And that doesn't work. How about just 59 minus 4?
Excellent.
55. Is that a winner? Bam, yes. So, you get an answer like that, look for the reciprocal. And the reciprocal is taking the next 2 numbers, combining them, 94 plus or minus 5. How much is 94 minus 5? I'll give it to you, 89. That doesn't work. How much is 94 plus 5? 99. And that corresponds to 99 99 over there. So we have a winner. And this happens most often if you can find one solution where you combine the first two numbers and subtract or add the third number. Subtract or add the third number and end up with 11 over a multiple. If you look at the second two numbers, the same thing will happen. We'll be able to arrive at a solution. Okay. Let me just take a couple quick looks. 9 times 5 is 45. That's not going to do it. There's a possibility. Does anyone know what 4 factorial is? It's 4 times 3 times 2. I'm going to let you figure that out. How much is 4 times 3?
12.
And how much is 12 times 2? 24. Equals 24. So, we can use 4 factorial. That equals 24. Plus 9 equals what? 24 plus 9. 33. Absolutely perfect. And since 33 is a multiple of 11, that means that we can multiply the 5 times 33. And even if we can't do it in our heads, I can't. We end up with another multiple, and we can say it is given. So we don't have to go through the math. We know that it will add up to or multiply up to a multiple of 11. All right. Now your brother brought a couple of license plates, and we'll take 2 from you and we'll be done. Give me a couple of numbers, please. I can't hear you. 1, 2, 0. Oh, that should be easy. 1, 2, 0. And this one's going to be an interesting puzzle. Okay. I see you raising your hand.
With the 0 into 10, 10 plus 2 minus 1.
10 plus 2 minus 1. 10 plus 2 is 12. Minus 1 equals 11. Perfect. Very, very good. All right. Anyone else see a possible? How about combining the 1 and the 2 in 12?
12 plus 10
12 plus the 0 used is 10
equals 22.
equals 22. Very good. That's also a winner. How about using the 2 as an exponent to square the 10? 10, then using the 2 as an exponent to square the 10, what is 10 times 10? That's it, 100. Then what do you do with the 1? Subtract, that's right. So 100 minus 1 equals 99. That's a winner. Right there. Okay, give me one more, which will be the last one we'll do today. I couldn't get 3, 5, 6. Well, table that because 6 and 5 all already been used, we've gone over that. 6 and 5 is 11, and then the 3 is 33. Let's try 7, 2, 4. Yes. Or you just trying to acquaint us with your beautiful, melodious singing voice? Okay. We already can see that the 7 and 4 would make 12 times 2. 7 plus 4 is 11 times 2. 22. So we can already make this into a 22. How about if we subtract the 2 from the 4? No, that would work. This one would still be left with 2. Okay, let's look. No, I can't see any further solutions to this. Okay. Cut!
Yeah.
I gotta get it ending now. Okay. This is going to be our ending, our last number.
Yeah.
It's 275. Do we have any solutions? Yes.
Just combine 75
Yes.
and then add 2
75 plus 2 equals
77.
77. Very good. Very good. Reciprocal.
What?
We just talked about reciprocals. Yes.
27 plus 5.
All right. 27 plus 5 equals
33.
32. Missed it by that much. But you're on the right track.
Yay.
So instead of adding the 5, what do we do? Minus. That's right. 27 minus 5 equals 22. So that was our reciprocal using these two numbers. And there's one more answer, and then I'm done with you for the year.
What?
That's it.
That.
2 times 7 is 14. Plus or minus 5, that won't work. 2 times 5 is 10, plus or minus 7, that won't work. How about 7 times 5? What is 7 times 5?
35.
35.
I go crazy.
And what do you do with the 2? Minus 2, there we go. Equals
33.
33. We have a winner.
Ding, 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 ding.